Recording, and we'll try this whole thing again. Right, welcome everyone. This is week 3 of the Charles Sturt webinar series on developing for Windows Phone. Make a quick note that unfortunately the labs haven't gone up online for this week yet. Both that and the recordings will go up sometime in the next 24 hours. The slides for this evening are already available online for those people who are either not on the call or want to review them later on. So today's session we're going to cover off a number of different topics related to interacting between your device and your application. So we'll look at things like location and maps. We'll look at some of the sensors in terms of the accelerometer, compass, those types of things. And we'll also look at how you can interact with the media aspects of the device. So for example, being able to play video or being able to deal with the speech APIs. Lastly, we're going to look at some of the new Windows Phone APIs around file and protocol associations. This is particularly good for passing data between applications or launching particular applications. We'll also look at NFC and Bluetooth in the context of being able to interact with other devices or being able to share data or communicate between different devices. Windows Phone 8 has got a new set of APIs around location. One of the nice things there, though, for those of us who have got existing Windows Phone 7 applications and they're upgrading them, is that the existing APIs are still there. So if you've been using the Geo Coordinate Watcher, that's still there. Okay, and the related classes around that, and in fact the Bing Map control is still there. We've now got a new set of APIs that has been ported across as part of the Windows runtime. That's now accessible from both managed and native code. So if you're writing native code, you can access these APIs from that code. There's better support for single point-in-time location acquisition. So by this we mean basically your application not interested in actual location tracking, so for the duration of your application. It's just interested in getting the user's current location when they spin up the application. In the past you could do this with the Windows Phone 7 APIs. But now we've got a little bit better control as to the precision and the accuracy and the timeout that we're going to set for that acquisition. And of course, as this is compatible with Windows 8, it makes it easier for us to build common code that runs across both Windows 8 and Windows Phone. One thing to note is that you do need the location capability, and just remember that by default most of these capabilities are now off. For a new application, so new Windows Phone application, most of these capabilities are now defaulted to off, which is different from Windows Phone 7 where they generally defaulted to on. If you don't have this compatibility set, you will get an exception raised when you try to use the location APIs. It's a bit of background around location. One of the nice things about the Windows Phone set of APIs is that it deals with the fact that you might be getting location from a GPS. You might be getting location from cell towers, or you might be getting additional information from Wi-Fi hotspots. Okay, pulling all that information together, and juggling the fact that you've got different data coming from these different sources with a varying level of accuracy, power, speed, and availability of them is actually quite difficult. So for the device to be able to pull this information, have a central source where it can retrieve information about and do the correlation between cell towers and Wi-Fi networks to an actual location is quite complex. And if we had to write that for every application, then it would be a very painful process. So the location services provided by the Windows Phone APIs wraps all of that and provides us with a set of APIs where we can retrieve location. We can track location from within our application. Now, in terms of actually the level of control that you have for which location service is being used, well, the short answer is that you can't control it. The slightly longer answer is, well, depending on the level of accuracy that you want, you can actually tweak the what they call the position accuracy, and you can flip it between either high or default. And the reality is that in most cases, if you turn on high accuracy or request high accuracy, this will probably trigger the GPS to be activated, whereas if you use the default option, then it's going to be optimized for power consumption and the availability of data. Okay, so if you've already got data available and it's just based on cell towers, you'll probably get that. Now, in fact, if you've ever used the Bing Maps control or the Bing Maps app on the device or the default mapping application, you would have noticed that by default it gives you a very large accuracy range when it first loads up, and then over time it refines that as it's got more data coming in. So in actual fact, the longer you track the data for within your application, the higher the resolution you're probably likely to see over time. Whereas if you just ask for a single point in time, it'll be a compromise between accuracy and the availability of that located data. You can also set, this is with the new APIs, you can now set the desired accuracy in meters. So for applications that want a little bit more control, you can set that. So here's a little bit of sample code that basically looks at this new class called the geolocator. This is new to the Windows Phone 8 APIs. And so here we're basically very similar to what you would have done with the GeoCoordinator Watcher in the past. We create a new instance of it, set the desired accuracy, and in this case we're going to look for a single position. So we're not actually going to track the position changed over time. We're basically requesting the current position of the device. And so we can specify things like the maximum age and the timeout. And clearly, if the position has been retrieved from the GPS or the location services within a certain time frame, in this case 5 minutes, it'll actually serve up that data rather than having to power on the device and actually go looking for that additional location information. Now, one thing to note is that the requirements for application certification are still consistent with Windows Phone 7.1. Now, in most cases, you don't need to prompt the user to turn on the use of location within your application. As part of downloading the application from the store, they'll actually get a prompt already, and that's just a form of consent. You do need to actually have an option within your application to turn location on and off, and the appropriate privacy policy to go with that. One caveat to that, though, is if you do plan to pass that location data onto another service, you do need to actually prompt and make it an opt-in policy as part of your application. The Windows Phone emulator, so this is both the existing Windows Phone 7 emulators and also the new Windows Phone 8 emulators, all have this ability to simulate location. So you can actually put push pins on essentially big maps, and actually you can track over time, and actually within your application it'll actually serve up those changing locations. You can also pass in a set of recorded data, and again that's allow you to repeat a particular part. So it might be that you actually go out for a walk with your device and actually track the location over time, bring it back as recorded data, and actually load it into the simulator so you can actually get some realistic data coming into or flowing into the emulator. Now, if your application does want to track location, you can now do this a couple of different ways. Firstly, you can do it as part of the foreground application, but we do also have the ability now to run our applications in the background so long as it's doing location tracking. So here again we've got a little bit of sample code that basically goes through roughly the same steps. The difference this time is instead of actually requesting the immediate position of the device, we're actually going to be attaching event handlers to both the status change and the position change on the geolocator. So as the position changes of the device, this event will get raised and we'll be able to handle that and surface up that information within the application. To enable location tracking in the background, so this is for when we want to track location when our application is no longer in the foreground. So the scenarios here are things like tracking a particular vehicle movement or potentially tracking a person as they go running. So the run tracking style applications is particularly relevant for. In the past, you'd have to do this and the application would have to remain in the foreground. The user went off to answer a phone call or they went off and looked for other things on the phone. The run tracking or the location tracking application would be suspended. With the new ability for location tracking to be done in the background, the application essentially goes into the background, but rather than getting necessarily deactivated, it actually gets put into this background running off mode. Okay. There's a couple of steps to actually enabling background execution. The first is to actually make a change to the app manifest file. So you can see here that we've replaced the default task with a slightly extended one which includes this background execution element. And in this case, the execution type is location tracking. The other thing we'll need to do is actually in the app.xaml file, we'll actually need to register an event handler for the running in background event. Okay, and essentially what happens is, rather than getting the deactivated event when our application goes into the background, if we're actually tracking location, so we do need to create an instance of the geolocator, we need to assign in the event handler. And then when our application goes into the background, rather than getting that deactivated event, we'll actually get the running in the background event. Okay, and you can see here that basically the sample code is, when our application is activated, it comes into the foreground, we're going to toggle the running in background flag to false, and when the running in background event gets raised, then we know that we're actually running in the background. And the reason why we're tracking this flag is so that when the position change event gets raised, we can actually determine whether we need to update the UI or not. Okay, so you can see here some sample code that basically illustrates, if we're running in the background, then we want to potentially raise a toast. Okay, so this basically can prompt the user to say, okay, this is the your new location, or we can actually update the position text, okay, on the actual UI itself. So we'll move straight across to maps. Okay, I mentioned before that the Bing Maps control will continue to work for applications that are being upgraded for Windows Phone 7, but also for applications that have been written, or for new applications being written using against the Windows Phone 7 APIs. There's a bunch of new APIs, of course, for the new mapping control, and bear in mind that the new maps control basically takes advantage of the Nokia maps, so the Navteq maps that Nokia own, and are surfaced throughout the Windows Phone 8 maps control. Okay, so to take advantage of those, the Nokia maps or the Navteq maps, the new mapping control is the way to go forward for that. You do also need to add in the map capability into the manifest file, and then once you've done that, creating a map controller is just as simple as creating the appropriate element within your XAML file. Alternatively, you can create it in code. Obviously, my recommendation is that you want to maintain as much of the design interface as you can in your XAML file. Unfortunately, the new map control is a little bit limited in terms of what you can do within the design surface. So, for example, don't get your hopes up that you can do any form of data binding. That's actually quite broken at the moment, and there's a few workarounds for doing that. And here we're just going to illustrate how you can wire everything up in code. So you can see here that we can go ahead and actually set the center and the zoom level. Now, in actual fact, if you're setting these to static values, you can actually do it in the XAML. But if you're trying to use data binding, then you're probably going to have to do it and write a lot of this in code itself. Okay, a big note here is that there's a complete lack of the default pushpin style. So you can't actually create a pushpin and just drop it onto the map. It's not available like it was in the Bing Maps API. However, if you want to create your own style pushpin, and to be honest, I actually found the existing Windows Phone pushpin to be quite ugly, and in most cases we actually rebrand that or restyled it based on the application that we're working on. So in actual fact, this probably won't affect too much. The downside is, of course, because you don't have those pushpin controls and the lack of data binding, it's very difficult, and you do have to write a little bit of code to get this thing to actually lay out properly. Okay, so essentially the strategy for creating your pushpins is that you just need to create UI elements, put them on a map overlay, and drop that map overlay onto the map layer, which is then placed on the map. Okay, so let's have a look at this in code, and essentially this is a method called createPushpin, and it's just creating a bunch of XAML, essentially, or UI controls, starting with a grid, and basically populating that so it looks like a pushpin. Okay, so that's essentially our method for creating that pushpin. Okay, so you can see here it's a whole bunch of polygons and points, so that it's going to have that pushpin style. Once we've actually created the pushpin, we're actually going to create a map overlay, drop the pushpin onto the overlay, set the geo-coordinate and the position origin. So bear in mind that the position origin basically determines where the coordinates in relation to in terms of the actual pushpin itself. And then we're actually going to create the map layer and drop all of this onto the map itself. In addition to the new map control, we do have a number of launchers that are associated with the maps. One of the big things about the support for maps on the device as a whole is that we've actually got the ability to have offline maps. We've got the ability for maps to be downloaded and made available to users when they're offline. And this actually, the set of maps is also available to your application. So if you want to make use of them within your application, you can actually prompt the user to go ahead and actually download them proactively. Okay. So there is a maps task. Okay, so this is basically to enable your application to launch the built-in mapping experience and actually drive the user to that. So we can see this on the right-hand side of the screen there. We've got a maps directions task. So again, we're providing directions, but rather than you having to recode a map with all of the directions and go and look it up and do all of that, you can actually redirect them off to the default mapping experience and actually pass it in both start and end destinations. Or in this case, we're just providing the end destination, assuming that the current location is the start location. And it'll go, the built-in mapping experience will go off and actually determine those directions and actually wire those into the UI itself. We've got the map downloader task, so this is what I was referring to before, when we can actually prompt the user to download specific maps for a region. And then, of course, we do also have the ability to update those maps. Okay, so periodically you might want to prompt the user and to say, we think you haven't updated your maps in a certain period of time. Suggest you go and actually do launch the map updater task. And actually, in fact, what this will do is it'll actually go to check to see if there's any updates. Obviously, if there's no updates, it won't download the full set of maps again. One thing to be aware of with the map downloader, the process is that it is quite time consuming. It should be done on a Wi-Fi network because the files are quite large in size. Okay, so now we're going to move on to some of the other features of the phone. So here we're going to basically talk about how we can go and read contacts and calendar information from the device, and then we'll move on to how we can actually go about creating some of that data as well. One thing to note is that there's a couple of things that your application should be obliged to do as part of interacting with the contacts and the calendar data on the device. So you should always prompt the user and request their permission. Okay, that kind of makes sense. There are examples on that people have talked about where they claim that Windows Phone is insecure, or that certain devices or certain other platforms are insecure, when literally it's a matter of applications taking advantage of the capabilities of the development tools to integrate with the contacts and calendar on the device. So, for example, people have said that Windows is insecure because it allows applications to read from contacts and then distribute them to remote web services, etc. But in actual fact, as part of the store process, it actually requires applications to indicate that they are going to request access to contacts and calendars. So we'll see this on the next slide. You do require the appropriate capabilities. And this need to actually prompt the user that you're going to be accessing their contact data. Now, if the user agrees to that and you actually indicate that what you're going to do with that data, then there's an element of responsibility that the user has to accept for that. Okay, as part of actually building up a better developer platform, Microsoft has done quite a good job at allowing developers access to these things in a relatively secure fashion. So the last point here is it's completely unacceptable for your application to essentially broadcast that contact data elsewhere. And so it's important the application does respect those requirements. As I mentioned before, you do need to specify the capabilities for your application. So there are ones for contacts and ones for appointments, depending on which capabilities you require. Now, within a Windows Phone, there's a number of different providers for contact and calendaring information. The built-in ones are things like Windows Live, Exchange, Facebook, but as we'll see in a few minutes, your application can have its own contact store, in which case it can be its own provider of this information. Okay. Depending on which of these providers you're interested in determines which contact and which calendar information you got access to. I won't go through this table in detail, but it's available in the slides just so that you've got information as to what data you can get. So, for example, contacts that are actually on the device, you can get all of the access to all of the contact and calendaring information, whereas data coming from the Windows Live aggregated networks, you can't access nearly any of the data at all. In order to access the contact, and the same with calendaring information, you basically need to find which data source you're going to be looking for. So in this case, we're going to look for the to see if the first account is an Outlook type. Okay, so you can basically determine the storage kind by actually querying the kind property. And there's an enumerated value here to determine all of the built-in types that are available for Windows Phone. Once we've got a contact source, we literally can write a query against that to pull back a list of contacts. So you can see here that we're actually going to do the search async to actually retrieve a list of contacts. And when that search returns, it's an asynchronous operation, so it actually returns as part of this search completed event handler. Once we've got that, the actual results of those we can actually data bind directly to the UI if we want to. So here we just this contact results data is actually a list box, and we're just setting the data context on there. So creating a contact, and actually the same goes for creating calendar. Your application can't interact directly or create directly a contact in the user's built-in data source. So for example, you can't create a contact in their Exchange account. There are a couple of different strategies that you can take to get around this. The first one option is to create a contact store for your application. This is available only in Windows Phone 8, in which case you can store, you can edit, update contact information, and those contacts will actually appear in the People Hub, and where they match an existing contact, you'll actually see a single contact card for that user. Okay, but just need to remember that those contacts are managed by the application. Alternatively, you can actually create a chooser that will actually prompt the user to save contact details onto the phone. Okay, this isn't particularly great because it doesn't give you the full fidelity of being able to edit and update or control those contacts, but it does give the user the ability to add that contact information directly into one of those existing contact stores. So we talk about launchers and choosers in the context of Windows Phone. Essentially, a chooser is an application that wants to go off and perform a task, or it wants to hand off to the operating system to perform a task, and then finally get a response from it once it's completed. So for example, selecting a contact or selecting an image. Once the task is completed, that data then comes back to the application is resumed and is able to handle that. Alternatively, a launcher is where the application basically is prompting the operating system to go off and perform a particular task. So this might be launching the maps, or it might be providing directions from point A to point B, or it might be placing a phone call or sending an SMS. Those are launcher activities because there's no return value that comes back to the application. So for example here, we're actually going to call the save contact task. Okay, so you see this, we've declared the actual task as a page level scope. The reason being is that we do need to make sure that this persists through both dormant and tombstoning. So for example, if we call the save contact task and then for whatever reason our application gets tombstoned, when the user finally comes back to our application, it's going to rehydrate, and if it's declared at the page level, then as part of the constructor to get rehydrated, the event handler will be reattached, and then the event handler will be subsequently called as part of the result coming back from the chooser. Once the chooser completes, the event handler we can query to basically say whether executed with an OK result, i.e. the data came back, and then we can actually process the return value. One of the nice things about Windows Phone 8, and we'll see this with a number of applications already, such as the Skype application, is that applications can create their own custom contact store. Okay, this is particularly good for storing information that the user might want to look up at some stage, but is relevant to a particular application. Because that contact store is specific to an application, it will get added and removed, or it will get cleaned up as the application gets removed, if it does in some states. So doing this is relatively straightforward. We need to firstly create or open the existing contact store for the application. And once we've got it, it's simply a matter of going and actually creating a new instance of a stored contact. Okay, setting a few properties on those, and then actually calling the save async method. Now notice that this actually makes use of the async await pattern, as opposed to some of the previous APIs where we saw they were asynchronous operations, but they had a callback or an event handler that got raised when the task completed. Okay. One thing to note is that because the data that you're adding into the custom contact store is not being added into the user's existing contact stores, so for example, it's not being added into their Exchange account, if the user goes into the contacts that you've added, so they'll be able to still see those contacts that belong to your application in the People Hub. And in fact, that sometimes there'll be even a marry up between their contacts that come from Exchange and the contacts that you've created as part of your contact store. If they actually go and try and edit one of their custom contacts, it'll actually prompt them and say, you can't edit these contacts, but you can add details to this on a contact card for one of your existing contact stores, so like your Exchange account. There's also APIs to allow you to read in and process vCard information, which can be particularly handy if that information is being served up by a backend service. So there's a number of other tasks that are worth mentioning. So save email tasks, save phone number tasks, and save ringtone tasks. These are all choosers as they return data back to the application. So just reiterating the difference between a launcher and chooser. Chooser, when it completes, will actually return data back to the application, whereas a launch will not. Here's a summary of some of the other choosers, not necessarily related to contacts. So we've got things like the photo chooser task, we've got camera capture task, we've got add wallet item task. We've got some other launcher tasks. Okay, so these are basically launching various parts of the device. So search tasks, web browser tasks, connection settings tasks, email compose tasks. There's a bunch of things that you can do from within your application or trigger off, including the new maps task that we talked about earlier. One nice thing that we can do within our application is actually create an appointment using a launcher. Now this is a launcher, so it doesn't return data to our application. And this is a new feature of Windows Phone 8 that basically will prompt the user to actually add an appointment into their calendar. In the past, we had the ability to actually create alarms and reminders, and we'll talk about those in a minute, which don't sit actually within the user's calendar itself, so they don't appear within the calendar application, but they do appear similar to a reminder or an alarm that would have been part of a calendar appointment. So here's the UI that gets presented to the user when you create one of these, or when you show the save appointment task. And of course, the user can go in and modify these values and even cancel the save appointment task if they feel like it. Just to note that in addition to the launches that we do have, you can actually launch various parts of the device just using the launcher URI async method. Okay, so here we can see that we're going to go through the settings, the lock screen settings area. And in fact, there's some areas of the device that are only available via this technique. So some of the new areas that are accessible, such as Zune and some of the marketplace queries. So here's some of the built-in apps that we can access using the URI syntax, and specifically some of the Zune or the marketplace or the store areas that we can access using this. So for example, we can do a query by publisher name, okay, by providing that URI syntax. I mentioned before that we can actually set alarms and reminders. We've had this functionality as part of Phone 7, the Mango update. So we can actually specify either an alarm or reminders or both from within our application. The distinction is that alarms will always have the title alarm, whereas reminders you can completely customize them, the content within them. The other thing is that the reminders do stack up. So for example, if you have a number of reminders that go at once, you can see here that this is illustrating one of two. So they'll basically stay in the front until the user is actually dismissed or snooze them. Okay, so it's particularly useful as a substitute for actually full integration into the calendar. Creating a reminder is relatively straightforward. Literally create a reminder object. You set the time that you want it to be raised, the content, and you can also specify a navigation URI. The one thing to note, you would have seen on the previous slide, is that the distinction between an alarm and reminder, alarms will always essentially just launch the application into the main page, whereas reminders will actually you can actually navigate to a specific page or particular URI within your application. In terms of housekeeping, in terms of cleaning up existing reminders, you can actually do a query to find existing reminders and actually remove them based by the name. So we're going to talk about the camera and the APIs that are available for working with the camera. And there's actually a number of different ways that you can work with the camera. The easiest way is actually to use the camera capture task, or this actually launches the camera on the device itself as a chooser. So essentially it will go off, it'll launch the camera, you can take a photo, and then once the user's done taking a photo, it'll actually return that data back to the application as part of the camera task completed event. Okay. So here we're basically going to process that, and we're actually going to display it on the screen just using a bitmap image. Another way is that we can actually use our application to actually capture the data itself. So we've actually got direct access to the video stream. So we can actually provide our own custom viewfinder. And this is particularly useful for things like barcode or QR scanners that we might want to build as part of our application. Here we basically, it's different from using the chooser syntax. So we can actually create a photo camera. We're actually going to set it as the source for a video brush. Okay, and once the camera image is available, then we can actually process that result and actually save the data from that. Okay, so to display the viewfinder, we're essentially just creating a rectangle on the screen, and we're going to use a video brush. And as you would have seen on the previous slide, we're actually setting the source to be this photo camera instance. So that'll actually provide the viewfinder on the screen. And then once we're actually going to capture the image, we basically use just the button click event handler of a button to actually trigger the camera to capture an image. And we can actually process that to actually save it through to the media library using the camera roll, using the saved picture to camera roll syntax. We can also display that image straight to the screen, again by creating a bitmap image and then pasting it as the source to the picture image control. Alternatively, we can save it to isolated storage. Again, this might be useful for actually for doing further processing, or just for images that are pertinent to our application and that we don't want to share between our application and make it available on the main device itself. A new thing in Windows Phone 8 is we've got another way to integrate into the camera experience by creating a lens style application. And essentially, this is enforced by specifying a new extension. Okay, and essentially this will register our application with the appropriate icons to actually appear as part of the camera experience. So as part of the camera experience, the user can pull out this list of lenses or lens style applications, which can be used to invoke our application. So again, when our application gets invoked, we're going to be looking for this static string, which basically says viewfinder launch, and use that to direct to the appropriate part of the application. In terms of processing the contents, this is very similar to what we saw before, where we're basically going to be working with the raw video stream. It's particularly good for sort of augmented reality application or for scanning applications, but increasingly we're seeing it for applications that just want to apply an effect to a particular image or to the video stream prior to it being displayed on the screen. So here we're going to do some funky image processing, just using a little bit of bit shifting logic, and bear in mind that this is going to be called for each pixel in the image. So again, we're going to use the photo camera class, creating a new writable bitmap that we're going to use to actually set this as the source for our image that we're going to display on the screen. And then what we're going to do is, after the camera is initialized, we're going to create a separate background thread, which is going to be used to process the data coming from the video, or coming from the photo camera object. Okay. So here you can see that for each time this runs, it's going to basically get the preview buffer. It's going to modify each pixel within the preview buffer, and essentially that then gets used to actually invalidate, or we're going to invalidate the writable bitmap, which will basically display the new image. Okay, so for each, and essentially this is going to happen for each frame that we can handle from the camera. Okay, and essentially so that this will actually happen prior to the image being displayed on the screen. The other thing we can do is we can also register our application to be an auto uploader for photos. So once the photo has been taken, our application can be the uploader for those photos into the cloud. And essentially this will get raised as a resource-intensive background task, and so essentially will be invoked when the device is docked or when it's being charged and is on a Wi-Fi network, rather than the user having to sit there and actually wait for the photo to be uploaded. The other sensors that we might want to integrate with on the device, we're going to move along to actually looking at the use of accelerometer, compass, and gyroscope. So the original Windows Phone came out with accelerometer support, so you could literally detect how the device is being interacted with. And then with the upgrade to Mango, we've now got support for both the compass and gyroscope on devices. Now, it's not to say that all devices have to have those. It's just to say that that it is supported by the Windows Phone set of APIs. In addition to that, we also have a motion class that actually brings these sensors together and makes it easier to interact with them. To work with sensors, we do need to import the sensors library onto our project and into the library where we're going to be referencing this. For each of the sensors, we do need to query whether they're supported. So we can actually query whether, for example, here the gyroscope is supported. And it's important that you actually do test before you make any assumptions on the availability of the sensors. Just a caveat to that is that the accelerometer will exist on all devices. I mentioned before that there's this motion sensor, and essentially this is an aggregated sensor that brings together data from the accelerometer, compass, and gyroscope. Now, in fact, if the gyroscope doesn't exist, it will fall back to just using the accelerometer and the compass. And that it provides some aggregate data based on combining the positives of each of those different sensors, and each one provides its own strength in terms of working out the positioning and the movement of the device. Okay, so the motion sensor provides attitude, it provides pitch, yaw, and roll, rotation rate, and of course the direction of gravity. One thing to note though is that if you don't have a compass on the device, the motion sensor is not supported. So it's really important that you do query that before you make assumptions on it being available. Again, like with the other sensors, the motion sensor is no different. Again, you just create an instance of it. You basically determine the time between updates. So this is how frequently you want the updates to come to it. And it raises an event handler for when the current value is changed. And that's your opportunity to actually invoke your code. So starting the actual motion sensor, this is recalling the start method. And then you get to handle the changed value in the corresponding event handler. Just one thing to note is that this can potentially happen on a different thread from the UI. So if you're going to make any changes to the UI, you will need to make sure that you call the dispatcher.begin invoke. Okay, we're going to flip back to actually deal with some video content now. There are a number of different types of video that you might want to play back on the phone. There is a full list of supported codecs on the MSDN website. Okay, here we're illustrating just the playback of a WMV file. But you can also support streaming videos. So for example, here we're providing a WMV file that's coming across the web. And in actual fact, there's also support, as we'll see in a minute, for smooth streaming content. We do have the ability to interact directly with the media element. So for example, here we've got this media playback media element. Okay, so it's a named element. And in this code, we're actually just calling the pause button, the pause operation on it. So you can actually interact with it to actually move within the media file and pause and begin playback, etc. I mentioned support for smooth streaming, and in fact, there's actually a full library for actually working with smooth streaming. So if you go to smf.codeplex.com, that's the smooth media framework that enables support for smooth streaming. Essentially, it provides wrapper logic around the core media element to enable you to use smooth streaming without you having to write a bunch of code of logic to go with it. We've also got now the ability to interact with speech on Windows Phone 8. In Windows Phone 7 we had very limited support for voice, and essentially it was restricted to be able to start an application or interact with SMS, so be able to read it back to the user or be able to compose an SMS. With Phone 8 we now have the ability to actually both do speech synthesis and accept command input and even speech recognition using the APIs. To enable speech synthesis, in fact all of the speech APIs, you do need to enable the speech recognition capability, and of course we need to reference the synthesis namespace. So in this case we're just going to read out a very short bit of text saying I like cheese. So we create the speech synthesizer and then we call speech text async, and remembering that this is an asynchronous operation, and in this case we're actually not interested in the return value, so we could actually just call this in a fire and forget way without the await prefix. If we actually want to play back generate voice in a different language, we can actually look and query for all of the installed voices, and in this case we're looking for the French language, and then we can actually set that as the voice for the synthesizer. So in some cases you might want to provide more control over the way that text is actually read out, and in this case you can actually use the speech synthesis markup language to actually control the spoken output. So for example in this case, instead of the output saying 12:35 p.m. As the time, well, it's actually going to be interpreted as a time and actually spoken out as 12:35 p.m. So you can actually use the synthesis markup language to actually control that type of output. We've also got the ability to control not just the launching of applications, but actually the interaction with our applications using voice command. So this is the example of a fortune teller program, and essentially when it's launched, it'll ask you, you can ask it a bunch of things, and it will supposedly give you a response. Okay, so the scenario here is that we've actually got a voice command definition file, and in that we basically have a command prefix, which is what the system's looking for in order to essentially launch our application. And then once it's detected that, it's then going to do the query for a bit of text that says, will I find? And then it's got a parameter in there which says future money. Now the future money can have a set of different values, so money, riches, and gold. So essentially the question will look like something like, fortune teller, will I find money? Okay, an example question. So in order to load the voice command definition file, we do that using the install command set for file method. Okay. And we do that as part of our application loading the first time. Once the voice command has been detected by the system, so the user would typically press and hold the Windows button and actually say, fortune teller, will I find gold? The phone basically will interpret that and determine that because I've prefixed it with fortune teller, it's going to launch an application. It's going to launch a command relative to our application. It determines that the launch page is money.xaml. So if we just step back to the command file, we would have seen that the target as part of the navigation is money.xaml. Okay, so when it matches this command, so the show money command, it'll actually launch this particular page within our application. So you can see that's the launch page, and our query string that gets provided in has got this query string that basically is made up of the command name, any phrase lifts, and recognized phrase. But then we'll also see that the whole phrase, as it was recognized, actually is passed in as well. So we've got the full fidelity of being able to control how we process that. So here is a bit of code just providing an example of how we handle the command as it comes in. So basically we're looking for the voice command name and actually processing that to determine what type of output we're going to provide back to the user. This is just an example of how you can actually then pull out the phrase list. Okay, so again that gets passed in as a query string, okay, a query string parameter, and actually we can pull that out what the user said or the option that the user specified. We can also dynamically modify the phrase list. So once the command set's been installed, we can actually query and update the phrase list on the fly. So it may be from time to time the phrase this changes. We can actually dynamically update those. In addition to doing voice command, we can actually do speech recognition from within the application. So we can actually trigger the voice listener, okay? And essentially that will integrate with the application and actually provide free text or the capability of actually recognize free speech back into our application. So here we're basically launching the speech recognizer UI, and we're actually going to get that data back into the application. We've also got the ability now to register file and protocol associations. So essentially we can now launch our application via either a file or a particular URI. So an example might be an email comes in with a custom file association. So it might be .randolph, in which case our application, which is already registered for that file type, will actually display a custom icon in the email. And it can actually, when the user clicks on that email, it will download the attachment and actually launch our application. Similarly, we might also have the Randolph protocol, in which case when a URI is launched that starts with the word Randolph : it'll launch our application and pass in those parameters into our application. To actually launch either a file or a URI from our application, we can use the launcher syntax. So launcher.launch file async. We can actually use that to launch a particular file that we might have within isolated storage or within app data folder. And that will essentially launch that file into another application on the device that's registered for that particular file association. We can also launch a URI, so launch URI async to actually launch a particular URI. And this can either be a standard URI, so it's HTTP, or starts with HTTP, or it can be one that is a custom protocol in terms of launching another application. Now, in some cases, there may be multiple applications registered for the same file type or same protocol type, in which case the user is actually presented with an option to choose which application to launch. This is slightly different to Windows 8, which has the concept of a default application that's registered for a specific file type or URI. To register for a file association, there's a couple of additional things that we can provide as part of editing the manifest file, and specifically the provision of logos to go with our file association. This is particularly important to give a good user experience. So, for example, if the user gets an email containing a .randolph file, it'll actually present a custom logo there so that the user knows which application is likely to be launched when they click on that file attachment. So here's the file type association extension within the app manifest file, and here we're basically providing a support for the .bqy file type. And you also notice that there's a nav URI fragment, and this is file token equals %s. And %s is actually the important part here. Is basically that's going to be replaced by the actual token that we're going to need. So it's essentially a GUID that we're going to need in terms of referencing that particular file. When the user actually launches that particular file, our application will be launched with this particular URI. So we're going to have to write a URI mapper to handle the file type association. So that's a static string that we've got to handle within our application. And then we're actually going to use the file token to determine the full file name and actually reference that file. So you can see here's a custom URI mapper, and essentially it's going to look for the file type association page. Okay, so that's not going to exist. It's then going to pull out the file token from that and use the shared storage access manager to actually retrieve the full file name. Okay, and so essentially it's going to do this switching between the file token and the full file name. Once we've got the file name, we can actually query the extension to determine which page that we're actually going to launch. So in actual fact, we've actually got two file types here. We've got the BQY and the BDP, and they're going to launch the bug query page and the bug details page respectively. And the other file type will just launch the main page of the application. Now, one thing that you do need to remember to do is actually to wire up the URI mapper into the root frame, and essentially that makes sure that when the application launches, it actually can handle those particular file types, and it'll actually use the URI mapper that you just created. Just a note in terms of how the interaction between different files, between different applications works. Essentially, regardless of which application the file is coming from, the files copied out of that application into essentially a shared storage area. So in here we've got emails, we've got a file coming web browser, and file coming from a third-party application. From shared storage, the launched application can then actually access that file and take a copy that it can then work with locally. So once we've retrieved the file name from the shared storage access manager, like we just saw, we can then also use the copy shared file async method to actually retrieve a copy of that file into the local isolated storage for our application, so we can start interacting with it. In terms of launching it or sending a file to another application, we literally have to get a reference to it, to the local file. So this might be a file that's within AppData or within the isolated storage or the local folder to our application. And here we do need to use the windows.storage namespace as distinct from the isolated storage APIs to actually get a storage file object. We can then pass that storage file object to the launch file async method. Just a note here that there are a number of reserved file associations. Okay, so these are basically file extensions that you can't use within your application. In actual fact, you can register them, but your application won't actually ever receive those files from, as part of the user launching it. And this is basically to make sure that the built-in experience for those first-party applications or file types is preserved. There's documentation online for the full list of those files types that are handled by the operating system. One note to make is that you do need to probably double check whether a particular file extension has already been used by another application in the store. As much as anything, it's very difficult to prevent collision of file associations. But if you create or register for a file association that's relatively unique to your application, you should be relatively safe. We've also got protocol associations, and these are roughly the same as file associations. The difference is that, of course, file associations is launched from a file. Protocol associations essentially launched from a particular URI. So here we can see the Contoso protocol, okay, and essentially what follows it is actually specific to the application, okay, so there's no default standard for what that syntax looks like. To add a protocol association, the entry in the manifest file is distinctly simpler than the file type association, but again we've got the actual protocol, and we've got the nav URI fragment that's going to be launched as part of our application. Okay, so here the fragment is going to be encoded launch URI, and again we've got the %s, which will include the information passed as part of the launched API launched URI. So for example, here the URI that will be that's being launched is actually the Contoso :show products. Okay, but what our application sees is we see a navigation to protocol. So again, we're going to need a custom URI to handle that, and then we've got a query parameter which is encoded launch URI, and then the actual launch URI is passed in as a parameter to that. To launch a URI from our application, so essentially we can use this to launch another application. And direct the user to another application, another third-party application, or as we saw earlier, we can actually use to launch different parts of, for example, the settings or the store on the device. Here we're going to launch the Jumpstart new session. Okay, so remembering that Jumpstart is the protocol, new session is just the data that's being passed with it. As with file types, there are a number of reserved protocols. So for example, you can't register for HTTP, file, IE history, etc. There's a full list of these online to make sure that you don't have collisions on those as well. The last section we're going to cover off is Bluetooth and NFC, and essentially we've got support in Windows Phone 8 for actually doing short-range communication. So in the case of Bluetooth, we've now got the ability to do app to device. So essentially this is the ability to establish a socket connection to any paired device on a Windows Phone device. For example, you might have paired a headset or some other peripheral and you want to establish a socket connection to that from within your application. You can now do that. What the second scenario supported is the ability to do app-to-app communication. So essentially this is establishing a Bluetooth connection between devices so that you can actually establish a socket connection between those two applications. In order to set up app to device, the important thing here is to remember that you do need to specify the proximity and the network capabilities. And we can use the APIs to basically query the list of paired devices. So here we're setting the alternate identities for paired, and then we're going to query using the find all peers async method. Okay. Now, one thing to note here is that there's a rather cryptic error that gets thrown if the Bluetooth is actually disabled on the device. If that happens, we can redirect the user off to the Bluetooth part of the settings, just using the launcher API we saw earlier. So here we see the launcher syntax for the settings for Bluetooth, and we can also use the connection settings task if you're more familiar with that. Once we've got data back from the peer finder, this will actually come back with an enumeration of peer information objects, and we can either display them like we are here, or we can actually use them to establish a socket connection. So here we're establishing a stream socket, and we're passing in the pertinent information from the peer information object, so host name, service name, and that'll give us back a socket that we can then use to interact with the device. Now, the important thing to note is that when we're connecting to a peripheral, the communication or the data packets that need to flow between our application and that peripheral is completely up to the device manufacturer. So if you're going to be connecting to a headset or some other third-party peripheral, you need to get in contact with the manufacturer to determine what the syntax or what the bit structure is that it's going to accept in terms of communication. App-to-app communication is slightly different. You do still need the proximity capability, but the important thing to note here is that the devices don't need to be paired. So, for example, if I've got my application I'm running on two different Windows Phone devices, I don't need those devices to actually be paired in order to establish a socket connection between those two. The process is relatively straightforward. Essentially, we wire up a listener for the connected request event. We set the display name and trigger start on the peer finder. This essentially sets our device into a broadcast mode. Once a connection is received, an event's basically raised within our device or within our application, where we can query the connection that's been requested, determine whether it's a device that we want to connect to, and then again we use this connect async method to establish the socket connection to that device. The thing to note here is that you do also want to call stop on the peer finder, otherwise it's going to continue to broadcast or attempt to connect or be available for connection, which will just drain the battery on the device. In addition to Bluetooth connection between either the two devices or between applications running on different devices, we've also got support for NFC, or near-field communications. And this is particularly good for a number of things, but one of the nice things about the Windows Phone implementation is it can actually be used to instantiate a Bluetooth or a Wi-Fi connection between two devices. Most people will be familiar with NFC in the context of using PayWave or similar payment technology. So, a lot of the credit cards now have NFC built into them so that you can actually facilitate a quicker payment process. So here's a couple of scenarios. We can use it to connect devices, as I mentioned before. We can use it to acquire content. So a number of posters that are now coming out actually have NFC built into them. You can put your device up to them and actually retrieve more information about the poster. And we can use it for the exchange of data objects. Or, so one of the built-in standards is the support for data to be passed as a vCard between different devices. So on your phone, if you go into the People Hub, select a contact, you can actually send it using NFC. Okay, so it's basically sets your device up to broadcast that vCard. So as I mentioned, there's essentially two ways that our devices can use NFCs, or our application can make use of NFC. The first is basically the broadcasting or the transmission of a simple message, and the second one is to actually use it as a mechanism to establish a Bluetooth or a Wi-Fi connection between two devices. To actually publish a method, essentially we're just getting access to the proximity device itself, so we're just calling get default. And that will actually give us the proximity device if one exists. Bear in mind that some devices, even running Windows Phone 8, won't necessarily have an NFC built in them. So essentially this will publish out a message, and then the flip side is that we can actually subscribe for a similar message type. Okay, and once a message has been received, we can actually process that message within our application. One thing to note again is that you want to actually make sure that you actually stop subscribing for a particular message, again to preserve the battery life on the device. To actually establish a socket connection between two devices, we can use NFC to actually establish that pairing. So here we're actually calling start on the peer finder, and we're actually going to register for the triggered connection state changed event. Okay. Essentially, this will raise a number of different events depending on the status of the connection attempt. Once we've actually completed the connection attempt, we'll actually get back, as part of the completed state, we'll actually get back a stream socket. Now, one of the nice things about this is it does enable us the establishment of a Bluetooth connection between the device, but it can also be used to establish a connection over Wi-Fi. Unfortunately, unlike Windows 8, it doesn't actually support Wi-Fi Direct on the phone. It'll actually just support a standard Wi-Fi, support connection over a standard Wi-Fi network. So essentially this evening we've gone through a number of different points of how our applications can interact with the device capabilities. I'd highly recommend that you do log on to the Online Learning Center site if you haven't already. There are a number of people who have posted questions, and it's a good opportunity to interact with other people on the webinar series. Don't forget to do the labs that will be posted within hopefully the next 24 hours. And also, if you're interested in keeping in contact with the developer community around Windows Phone, I'd recommend signing up at wpmsdeveloper.com.au if you haven't already. As part of that, you'll be notified of events, news, competitions. It's actually run by Dave Glover from Microsoft, and he's really good at pushing out those types of events. And particularly now, there's a couple of competitions that are running that you might be interested in participating in. All right, with that, I'm going to open the floor for some questions. So let me open up the questions manager and let me see what I can answer. Right, so the first one from Trevor is to do with the accuracy range on presumably the geolocator. Trevor, actually it depends on the device itself as to the resolution that you're going to get with the GPS on the device. I'm guessing it's probably only down to about 20 meters, but you may get better accuracy depending on the availability of some of the Wi-Fi information points. So that will vary by country, and the amount of triangulation you can do on the cell towers as well. Do I need to register for using the maps as in Windows Phone 7? Trevor, I think with the Bing Maps control, yes, you still need to register for it, but my understanding is that for the new Nokia Maps, because it's a specific control for Windows Phone, I don't believe that you do need to register for that any further. The simple way to test that is to put a Maps control on and just check to see whether it's got a credentials required prompt on it. I think you'll see that the Bing Maps control does, but when you use the new map control, it doesn't have that. Is the push bin still available for Bing Maps? Yes, all of the existing APIs for the Bing Maps are still there, so the push bin is still there. I would recommend, though, that if you're building a new Windows Phone application, that you actually use the new Maps control, because you'll get a number of efficiencies out of there, particularly if the users downloaded the local maps, which they may have done for Nokia Maps or Nokia Drive. They're all using the same set of maps. So if they download it for one application, it'll download it for all. So you'll get much better performance out of those. Bruce asks, what is the limit of polygons on the map control before performance degrades? Also, does map control support custom tile layers? Bruce, to be honest, I don't know about the custom tile layers. I'm guessing it probably does. I've heard pretty good feedback from a lot of the map specialists that have been starting to use the map control. I think that you're likely to get much better or a much higher number of polygons on the new map control than you would have on the previous one. I mean, one of the reasons why we switched across to the new maps control is for performance reasons. And in actual fact, that's the reason why, or one of the reasons why there's no data binding support, is because they found that too many people were abusing it, and it was just degrading performance of the maps. Trevor asks, is there a function to get reminded names from searching? Sorry, Trevor, I actually don't understand what you're asking there. If you want to elaborate on that question a little bit more, I can get that. Is there a function to get reminder names from searching? So, sorry, Trevor, are you asking whether you can just query to get back all reminders? Okay, we might come back to that one. We need to call start to start the sensor before the app exits. Do we need to call stop? Yes, at some stage, unless you want to continue tracking the location of the user, you'll need to call stop at some point. Otherwise, your app will continue to run indefinitely. Now, I think that there are some caveats on that. Is that I think there's a 4-hour limit on how long you can track location for. So if you're going to be doing that location tracking, you do need to compensate for a couple of things. Firstly, after a certain amount of time, the user's battery is going to get drained. Second of all, there is this 4-hour window after which your application will actually get terminated, is my understanding. So, Max asks, does the media player give video controls play pause automatically? So the media element itself doesn't, but the smooth media, the media framework, which you can download, actually does have built-in controls for doing play and pause and things like that, and it's all stylable, so it's actually quite useful. Max also asks, launching app using voice, so it allows the user to launch the app straight from the start screen. Yes, so essentially they do still need to press and hold the start button, which we had in Phone 7, so they press and hold that, and and in the past you used to have to say start and then the application name, and that would launch it. Now you can customize it more, so in the case of Fortune Teller, the app name doesn't actually need to be Fortune Teller. The command that's registered as part of that application has the command prefix Fortune Teller, so that's what's used to determine which application and then subsequently which command is then invoked as part of that voice command. Is there a way to obfuscate the code before publishing the developed apps to the market? So there's a couple of things here. Yes, there are some obfuscation tools out there that people have used in the past. The thing about obfuscation is it probably doesn't yield any benefits to you anymore, because it's basically impossible for the user to and I won't say totally impossible because I'd never say never. It's very difficult for the user to actually intercept your application and decode the logic. In the past, it used to be quite straightforward because the ZAP file was held in plain text on the store. So as the user went to download the ZAP, you could intercept it, get a reference to the URL, pull down the ZAP, change it to a zip file, and actually get access to the DLLs. Now, when you actually submit your application to Marketplace, the Marketplace actually does a couple of things. Firstly, it actually does a native compile of your DLLs, and that's actually primarily for performance reasons. The ZAP file, the DLLs and ZAP are all signed again by Microsoft, as they have been in the past. But then the whole ZAP file is actually encrypted, and it uses the same technology they use for DRM protection in the Microsoft space. So it uses PlayReady, and essentially that limits it to Windows Phone devices to actually decode that. So essentially your application will be downloaded from the store, encrypted, it'll be decrypted and expanded on the device. So unless the user was actually able to basically take an image of the device and then decode the file structure of the device, they'd actually be unable to get access to your code itself. That said, of course, if you've got super secret logic, you should just keep it on a server somewhere rather than actually embedding it within your application. So Regan asks whether to use the email compose task or launch Mail2. Regan, I think you're probably going to find a little bit more fidelity with the email compose task, just in terms of setting things. It just might be easier than trying to compose a full URL to launch using the Mail2. In terms of which is better, neither. They both do the same thing. You've got to remember that a lot of these tasks came about because we didn't have the ability to use the launch syntax, so the ability to launch a particular URI. So you can think of the mail-to syntax superseding the email compose task, but in actual fact, I find the email compose task to be slightly better because it actually gives you, strong syntax for setting subject and setting the recipients and things like that. What if there's a conflict with the voice commands? Good question, Max. I think that it probably goes down to whichever application was installed first. And it probably uses that. Or as part of this syntax for the voice command, it may actually prompt the user to say, okay, well, it's detected two different applications, both with the, for example, fortune teller prefix. And it will prompt the user to pick which application they want to, or which command they want to launch, would be my guess. So that's the end of the current questions that are listed in the window. We've still actually got a few minutes before we're due to end. So feel free to ask any other questions. Just moving the window around to make sure that you can all see the URL for the learning site. If you're sitting here waiting for the session to end, I do recommend that you log in there and make sure that you've got access to it. If I host my own service, which the app can use, people can find out the URL I'm connecting to. So is encryption the only answer to secure the app to service communication? Yes, essentially, Max, that is probably the only way that you're going to secure it. And to be honest, even then, you've got to remember that if the user wants to, they could run the app on a device that is going through a proxy. So, for example, they could route it through Fiddler, in which case they could actually see what's going, even if you're running on a secure string, on an SSL style connection. So, if you're really paranoid about it, you can provide a second level of encryption beyond that. But bear in mind that the users are likely only to be able to do that on a connection that they've got. Okay. Trevor asks, I tried to find the options to upload my app for Windows Phone 8 and still keep Windows Phone 7, but not sure where I'll have to do it. So the strategy there, Trevor, is that you actually need to submit your Windows Phone 7 app first, and then you submit the Windows Phone app as an update to that. Sam says, does NFC information go both ways, or is it read-only? It actually depends on the device or the NFC that you're interacting with. So in most cases, for example, NFC tags, you can, a lot of NFC tags are actually read-writable. So in actual fact, somebody was saying the other day that they kept on using the NFC capability on the phone against a lot of posters, and then end up getting rickrolled on the device because some clever person has gone along and actually recoded all of the posters. And essentially what's happened there is the manufacturer of the poster has actually forgotten to close the tag. So you can actually buy NFC tags in bulk, and actually they come in a state where you can write to them. In actual fact, most of those tags you can write to multiple times, and then you can actually close them off so they can't write anymore. And at which point they basically become read-only. So your phone, when you bump it against that, will actually be reading that information from the NFC tag. Now, phones are slightly different because, of course, you can actually broadcast a message and also receive message. So as part of the APIs, you can subscribe for a particular message type, or you can actually publish out a specific message type, depending on whether you want to send or receive messages. So in actual fact, if you're interested about using NFC, there's actually an application on the store called NFC Interactor that's quite useful for both writing NFC tags from the phone, but also reading NFC tags. And so I mentioned before that a number of the Nokia peripherals actually use NFC to configure the device. So, for example, the speakers, when you actually place the device down on the speakers, it'll actually mute the default speaker on the device so that it should broadcast just straight through the external speaker. When you actually, if you actually run the NFC Interactor application, you can actually see what the NFC message is actually on the device, on the speaker, for example. Bruce says, is there a limit on the file size over NFC transfer? Bruce, to be honest, I'm not sure. I know that there are some constraints on Windows Phone about the type, the structure of the NFC message that you're sending, or the NFC capabilities. So I think it is somewhat limited in that you do need to send out a specific message type. It's not particularly good for sending whole files, and as part of doing that, you probably want to use something like establishing an NFC, using NFC to establish a Bluetooth or Wi-Fi connection to another device, and then actually use that connection to actually send a larger file down. Obviously, it is used for distribution of vCards, and that's a sort of a standard message structure that's well understood by devices. So Max asks, I'm now worried more about hosting my own services. I don't want other people to be fiddling with the services. Yeah, Max, look, that's always going to be a problem with remote services. There is always the risk that people will interact with them in a way that you don't or are not expecting. There are a couple of strategies that you can use to do that, to impartially solve that. You can do so, for example, if you're interacting with the Microsoft, the Windows Azure services, so for example, blob storage, one of the strategies that they've got there is this concept of a shared access token. So essentially the user, the device would have to authenticate to a service. They get a shared access token that basically gives them limited access to the set of services. Of course, if the user actually, if the person who wants to fiddle with the services works out your model for doing it, so they go through that authentication process, then they'll get the token and they can then use that to interact with your services. So it is a trade-off between making services public versus preventing people from interacting with them. And I mean, yes, I mean, if you in order to get around those, you would probably need to provide some sort of double level of encryption with some sort of a key embedded within the application. I think, Max, that in the short, the standard response to that, or the standard way of handling that, is to make sure that all of your requests are done in an authenticated manner. So making sure that the user is currently authenticated, and then having some form of a token that you pass back with each request, because at least that way it limits the amount of interaction that any particular user can do. Yeah, so maximum. Actually, my suggestion around having the key actually embedded in the app was actually to say that if you have the key within the app, then you could use that to encrypt the payload, which is going back and forth between between the device and the server. SSL isn't actually enough in that case because you can an end user could potentially run it through something like Fiddler, which actually spoofs that could be used to spoof the SSL. So actually, because SSL only works to the service. Essentially, what you're saying is that you actually want to make sure that you provide a secondary level of encryption between your application, the inner workings of your application, and the service itself. So, and you could do that by actually having the key deployed as part of the application, because they won't be able to decrypt the application itself, so the ZAP file, in which case they can't actually pull out that key. Another question, I can create appointments using the save appointment task, but my application cannot delete the appointments. Any reason for this? Yeah, I mean, for the same reason as you can't actually delete contact or edit contacts in the main contact store. To be honest, I would have almost preferred to see Microsoft do the same as what they've done with the contacts, and essentially have the ability to create an appointment store within the application, in which case you can actually create, edit, update, delete appointments that are specific to the application within that, and then for those to be surfaced with the calendar. I think that would have been a better approach rather than creating this save appointment task. The save appointment task, in the same way as save contact task, just gives you the ability to basically publish out an appointment so that the user can save it into their calendar. It's like if you were to take an application that makes that creates an event, for example, or say creates a booking somewhere, you could use that to then prompt the user to actually save a calendar for that particular event. But again, it's kind of weak because if that event was to ever change or the booking was to change, you can't actually update it. What was the intended benefit of using the lens feature of the camera just for funky effects? So the concept of lens is basically to provide a better way or an easier way for the user to get from the point where they're taking a photo to actually using a third-party application to provide visual effects as part of the process of taking a photo. So it's a combination of modifying the viewfinder or showing how the camera image is going to look with those effects applied. Is that concept of a lens? So, because in the past we could only really the interaction with the photo or with the photos part of the device was actually limited to the ability to register as a sharing application or to register as an editing application. So that was post the user actually taking a photo. Now it's really about trying to engage with the user before they've actually committed to taking the photo and actually allowing the application to apply a lens or apply some effects to the photo as part of it capturing it. Regan says, or asks, lens in real time with computationally expensive can drop down to Neos or something. So, Regan, I don't understand what you mean by the last part. Are you referring to just dropping into native code for applying doing that, the lens type operation? Because yes, I mean you can integrate native code to basically do some of that lens processing at that point. And actually, part of the intent here is that, or the way that Microsoft's in. Okay. Thanks, Regan. I didn't know about MMX on ARM. So Max says, wasn't the funky effect code you showed using C++? No, actually that was just in C#. Max, it was just using bitwise operations. You can either write the entire lens application in native code, or you could switch to do the computational logic in native code. at that point. I don't believe that you've got the ability to drop down directly down to processor-based operations or any sort of hardware rendering for that type of thing. But to be honest, Regan, I'm not a guru in the type of operations you can do as part of that operation, the lens style operation. I think if you're going to go down that path, you probably do want to consider doing it in native code to get the maximum performance out of that. If you're interested, I do have contacts in that space that I can put you in contact with. So just probably post a message in the forums, and I'll try and answer it during the week and put you in contact with the right people. Trevor asks, can I encrypt my database now or put password? So if you're using SQL Compact, you could actually encrypt it just by specifying a password as part of the connection string, I thought, for back even using Windows Phone 7. Again, I'm not sure that you really get any value out of that other than if you were to distribute that database off the device, bearing in mind that the isolated storage area on the device is protected from both other applications, and it's going to be very difficult for somebody to actually get a copy of that database off the device. The other thing to remember about Windows Phone 8 is that the device itself is actually BitLocker protected, so the device itself is actually encrypted, and that's actually been done to make sure that we can pass things like sort of the government regulations around the requirements around encrypted data stores and things like that. So hopefully, Trevor, that'll answer or that'll satisfy your needs in that area. Should I develop my game using a game engine? Yes. Why? No. Why? Okay. So I'll put the caveat that I'm not a game developer. My understanding is that I guess the gaming logic that you require for a good game is substantially different from a standard app. One of the nice things about XNA is that it did have that game loop as part of that, so it gave you sort of the fundamentals for doing that. I think if you're going to build a game for Windows Phone 8, then you typically be doing something like DirectX using native code. And as such, I would probably consider using a gaming engine or one of the third-party tools like Unity when they actually support Windows Phone 8 to actually use that to build out your game. Because the biggest reason for using an existing gaming engine is that it's just going to save you a substantial amount of time in terms of actually creating your game. Are there any good game libraries to start learning? There's so many to choose from. Max, unfortunately, I'm not probably the person to ask for about that, as I'm not a gaming guy. Again, if you can ask during the week on the forums, I'll see if I can grab one of the other guys. One of the guys from Nokia, so Vaughan, is probably one of the better people to ask about that. I can just get him to follow up about those game libraries. And as Regan says, yeah, Unity is quite expensive, but you get quite a lot for your dollars. Apparently, it does make game development substantially easier and quicker, and particularly with their support for a number of the other platforms that are out there. So it means that you can essentially write your application or write your game once and get it cross-compiled. All right, we've got a couple minutes over time to make up for the slightly delayed start due to my microphone being on mute. I would encourage you guys to all participate in the forums during the week. Keep on asking those questions and interacting with other people in the webinar. Thank you all again for attending, and look forward to catching up with everyone next week. Thanks, guys.